In this video, we're going to look at an example of how we can integrate using partial fractions. So say we want to find the integral of something like this. Say we want to find the integral of 1 over x squared minus 2x minus 15 with respect to x. And we're not really sure what to do with this. How can we make this simpler? Well, the first thing I see is that we can factor our denominator, right? So we can rewrite this and say, let's find the integral of 1 over x minus 5 times x plus 3, right? We just factored the denominator. It's still equivalent with respect to x. And now something that might make this easier is to split this fraction up into two fractions, which we can then take the integrals of and add together, right? So if we want to split this fraction, we're going to have one of our terms over the factor x minus 5, and then another one of our terms over the factor x plus 3. Yet we don't really know what goes in the denominator yet, right? We'll call those a and b, right? So we have a over x minus 5 plus b over x plus 3, right? And this is equivalent to our split fraction, right? So this is going to be equivalent to 1 over x minus 5 times x plus 3. So one thing I want to do is kind of eliminate our fractions, right? And we can do that by multiplying our entire equation by x minus 5 times x plus 3. So if we get this whole thing and multiply this by x minus 5, x plus 3. What this then gives us is we get a times x plus 3, because the x minus 5's canceled each other out, plus b times x minus 5, because with this one the x plus 3's canceled out, and then equal to 1. Alright, so now we're close, and now we want to just solve for a and b. Now, a way that I think is easy to do this is to choose an x that will eliminate our a and b. So what does that mean? Well, specifically, a is being multiplied by the weight x plus 3, right? So what I'm going to do is say x is equal to negative 3. And then when we plug that x into our entire equation, right here, this is going to cancel out. Negative 3 plus 3 is 0, so then we get a times 0, and that goes away. So what we end up with is 0 plus b times, and then negative 3 minus 5, that's negative 8, is equal to 1. And then when we solve for b, we find that b is equal to negative 1/8. And we can repeat this process to find the value of a, right? We could say that x is now equal to 5, right? Because then this will eliminate the weight on our b side, and we'll end up with a times 5 plus 3, so that's 8, plus 0 is equal to 1. And then we get that a is equal to 1/8. So now that we have values for a and b, we can plug these back into our integral and start evaluating it. So let's do that. We will have the integral. Let's write this right here. The integral of 1/8, and since 1/8 is going to be in both of our terms, we can actually pull that out in front of our integral, right? So we'll have 1/8, and remember that was for a. We're going to end up with 1 over x minus 5 minus 1 over x plus 3, and the reason it's minus is because b was negative 1/8, right? So that's why we still have that minus sign. So we have minus 1 over x plus 3 dx. And again, this can be taken as a separate integral, so we could say that this is 1/8 times the integral of 1 over x minus 5 minus 1/8 the integral of 1 over x plus 3. And this is where knowing the derivative and integrals of natural logs of functions is helpful, because that's what you're going to see for a lot of your answers with partial fractions. So if you're familiar with these integrals, you know that our answer evaluates to 1/8 times the natural log of x minus 5 minus 1/8 times the natural log of x plus 3. And that is how you do partial fraction integration. And don't forget your constant of integration plus c. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.